As you remember from a previous video, digestion is the breakdown of foods that we eat into molecules that we can absorb. The digestion of carbohydrates begins in the mouth, where food is chewed and mixed with saliva, containing the enzyme amylase. Amylase works on the large chain starches, converting them to shorter polysaccharides and disaccharides such as maltose. The action of salivary amylase is short-lived, however, because once you swallow your food, the acid environment of the stomach causes amylase to be denatured and thereby inactivated. Digestion of carbohydrates resumes as food passes from the stomach into the small intestine, where the bolus of food is now called chyme. Amylase, produced by the cells of the pancreas, is added to the small intestine by the way of ducts. The action of amylase in the small intestine is identical to the action of amylase in the mouth, resulting in short starch chains and disaccharides. The digestion of starch is completed in the small intestine by three enzymes coming from the microvilli or brush border of the small intestine, namely maltase, sucrase, and lactase. These enzymes act respectively on maltose, sucrose, and lactose, causing the hydrolysis of the disaccharides to their corresponding monosaccharides. These monosaccharides are then absorbed into the epithelial cells that line the villi of the small intestine. Glucose and galactose are both actively transported into the cells, requiring energy in the form of ATP. Fructose, on the other hand, is absorbed by facilitated diffusion, which does not require energy, but does require more time. So, large doses of fructose are not readily absorbed and can contribute to diarrhea as the monosaccharide remains in the small intestine and attracts water. Once absorbed into the intestinal epithelial cells, these newly absorbed monosaccharides enter the capillary network located inside the small intestinal villi. These capillaries converge into larger and larger veins and ultimately the hepatic portal vein that delivers blood away from the small intestine and to the liver. Fructose and galactose are converted to glucose in the liver. Thus, all absorbed monosaccharides end up as glucose. The condition of lactose intolerance is associated with a decrease in the production of the enzyme lactase. This condition is quite common after ages 3 to 5 years old and may affect as high as 75% of the population as we age throughout adulthood. However, most people can tolerate small to moderate amounts of milk and dairy products without symptoms. Even if you are affected by lactose intolerance, it does not mean that you have to give up milk and dairy products altogether. There are several remedies that are available. Dairy products are available that contain the enzyme lactase already added, therefore causing lactose to already be converted to glucose and galactose before you eat them. Pills are also available containing either lactase or the acidophilus bacteria that breaks down lactose in your GI tract. If those products don't work, switching to one of the many different non-lactose containing milks, such as soy milk, almond milk, or rice milk, may be tolerated better. Nearly 90% of consumed carbohydrates are digested and absorbed. The remaining 10% includes fiber and resistant starches. Bacteria in the large intestine ferments soluble fiber into such products as acids and gases. The acids, once absorbed, also provide calories for the body. In this way, soluble fibers provide about 1.5 to 2.5 kilocalories per gram. The remaining fiber passes through the GI tract as feces. In our next video, we will talk about what happens to newly absorbed glucose and how we regulate blood sugar levels.